Hello there, welcome to the learning of engineering tutorials. In this video lecture, we are trying to learn the strain energy stored in a rectangle object, but this time that member is going to be subjected to the shear strain or shear loads. So then we can see here how the shear forces are going to be acting. It is always acting tangentially to the surface of the member, right? Suppose in the previous classes we have seen, in the previous video lectures, that's going to be the strain energy stored in a gradually applied load, suddenly applied load, and impact load also we have calculated. Now we will see the strain, how it is going to be acting. Now for this one, I have taken one rectangle box. I am going to be applying the load tangentially. So then what will happen? Tangentially means that load is going to be coming on the surface of this one. This is going to be the P. Alright. So then suppose if I am going to be fixing at the bottom. So then what will happen? When the force is going to be coming on the surface, so then what happened? The layers are going to be forming from this side. So that I have representing in the two-dimensional over here, that's going to be rectangle box I have taken. This is the face I have taken, right? This is the face I have taken, that's going to be your A, B, C, D face, that's going to be A, B, C, D. Now I am going to be applying the load in this direction that represented there. So now the member is going to be trying to distort its face, so then it will reach to the new positions. So this I am going to be calling the D dash, this is going to be your C dash, and the gamma is going to be the shear strain or the shear angle, it is going to be a framing. Now how to find out here the strain energy? So there we can see the tau is the word we are using, that is the shear stress, gamma is going to be your shear strain, and G or C we are going to be calling, that's going to be modulus of rigidity. Now I want to find out the shear stress. So then shear stress is equal to, what is the formula? The shear load by area we are taking. Here is the shear load P by A I am going to be considering. Now can you see which face is going to be distorting? So that means this face is going to be start to distorting, that means going to be your length face as well as this B face is going to be start to distorting. So that I am going to be writing P into L into B I am going to be considering. Then finally the load P is equal to tau into LB I am going to be taking. Once if I am going to be getting the load in terms of the shear stress and the area which is going to be suffered due to the strain. Now I am going to be considering shear strain is equal to, that shear strain is equal to, can you see this is the inclination, that is the gamma, opposite side is going to be C dash by BC I am going to be taking. This height I am going to be considering as the H, right? So that gamma is equal to, so that's gamma is equal to here, that I am going to be C dash by BC I am going to be taking. AB length I am going to be considering, that is the L, right? And this is going to be the B, and this is the L, and this is the H. So that is the rectangle. So then this equation, the C dash is equal to, what is the formula? Gamma into BC. BC is equal to how much? That's going to be the H, we got it. So these two equations we are trying to use to find out the strain energy, right? As we know, the strain energy we are going to be writing in terms of the shear stress. So then we know that is equal to the work done on that system. So here the shear force is going to be there, that is going to be acting. So then what is the formula for this work done? Work done is equal to the load into the displacement we are going to taking. Suppose it is going to be the P into C dash we are going to be considering, right? So that's the P is equal to, so that we are going to be considering here, that is the average load we are taking. That means here this P is going to be acting gradually. So then again we are going to be taking the load and displacement curve, and then we are going to be taking the average load. That's going to be P by 2 into C dash. So now we are going to be substituting what is the P is equal to, that's going to be tau into LB, right? And C dash is equal to gamma into H. So that is equal to, the P is equal to tau LB divided by 2, the C is equal to gamma into H, alright. So then I am going to be rewriting this equation. So if I am rewriting that equation, that is the work done by the shear force that we have taken, the average load is equal to tau by 2 into gamma into LBH, LBH is going to be representing your three-dimensional objects that I am going to be say tau by 2 gamma into volume I am going to be writing. So in this case, the gamma I want to rewrite in terms of the another equation. That's going to be shear stress as well as the modulus of rigidity. That's going to be GRC, that is equal to shear stress by, what is the shear stress here? That's going to be tau by gamma I am taking. So from simplification, gamma is equal to tau by C I am going to be considering. This value I am going to be substituting in this equation. So that's the work done, or strain energy due to the shear stress or shear strain, that is equal to tau by 2, gamma is equal to tau by C into volume. That is the strain energy is equal to tau square by 2C into volume. So this is the magnitude we have derived when the member is going to be subjected to the shear stresses. If the case, the gradually applied load, then what the strain energy we are getting, gradually applied load means sigma square by 2E into volume we are getting. So this is the load is going to be subjected, that's because of the tensile load, right? That is the tensile load may be gradually or suddenly, or impact load is going to be coming. But in this case, what will happen when the member is going to be subjected to the shear stresses, that's going to be tau square by 2C into volume we are getting. So this way we have developed the mathematical model to determine the magnitude of the strain energy. This strain energy we are calculating within the elastic limit, right? So then those values we are going to be substituting, and finally we are determining that part. So thank you. So still if you feel any confusion, then put in the comment section so that I can reach you out. Thank you.